Hi, I'm Isaac, and I'm going to be talking about our entry into the RE2 DREAM Challenge, which won the overall damage prediction category. For more details, you can see our write-up on Synapse, and this is our contact information if you'd like to get in touch. So roadmap, I'll talk a little bit about the challenge itself, then about our overall strategy, give some more details on our methods, and close with what we think is an interesting open question. The challenge itself is to automate rheumatoid arthritis joint damage scoring, specifically the Sharp-Van der Heide method, which, as you can see, requires coming up with a bunch of different damage scores on individual hand and foot joints, or in machine learning speak, predicting many different features for each input image. Overall strategy, we tried for something that was simple and hopefully useful in the clinic. So we chose not to use ensembles, which is a common machine learning competition technique where you train many models per task and then combine their predictions. We tried to just train one good model per task. And we also didn't adjust individual joint scores based on the other joint scores from that patient. This was based on some discussion with doctors who said that what they really try to do is score each joint independently. And we'll come back to that later. More strategy, as you can see, the training set is pretty sparse, but what we're trying to predict is relatively complicated. So we would like to use a powerful model like a deep neural network, but we have to be careful to avoid overfitting. So how did we do that? The main trick, which was used by all the winners, is to cut out joint images and then use one model to predict multiple joints. That has two benefits. It greatly increases the training data per model, and it also decreases the image area the model needs to train on. So more strategy, we used Fast AI, which is very good at avoiding overfitting. We gave some careful thought to data augmentation. For example, we used the warps shown, which we thought could simulate joints being held at different angles to the X-ray plane. We did a careful search for a good pre-trained architecture. We found that DenseNet performed the best, and some other standard stuff like cross-validation. Our methods, we had 3 stages. In the first stage, we trained a model to rotate all the images into the same 90-degree orientation. I'm not going to say much about that because it was pretty easy to get to a model with 100% accuracy. The next stage was to locate and cut out the joints. To do that, we trained models to locate the centers of each joint. And in order to make the training set for that, we wrote a mini GUI to manually mark the centers of all the joint images, of all the joints in the training images. And then again, once we had that, it was pretty easy to get to a high accuracy model. A couple of more details on the joints. For the wrist joints, which are harder to localize, we divided the 12 wrist joints into 4 groups of 3, and we only predicted 1 point for each group. And then to actually cut out the joint images, we just cut out a square at the predicted center, which was of a certain percentage size of the original input image. Finally, to do the joint damage prediction, we grouped joints as shown, and we trained a model for each group. And this training process was harder, so we had to use some cross-validation to select the best hyperparameters. And then, as we said before, we didn't make any further adjustments to the joint damage score. That was our final output. And that brings us to what we think is an interesting question. Should we do that adjustment? In other words, does it improve accuracy to adjust the individual joint scores based on the patient's other joint scores? Or are we, in effect, just training the model to duplicate human error? So we did a little analysis of the training set to look at that. We grouped the finger and toe joints into horizontal groups as shown. And what we found is that the high damage tended to cluster in nearby joints within each horizontal group. So our final question is this clustering real, or does it arise because doctors tend to scan horizontally through the joints when they're doing the scoring? If you have any thoughts on this, please let us know. And thanks for your time.